Yeah, hello, this is Dr. Hoffman from the Department of Chemistry and Biochemistry. I'm going to share some details about our various degrees. So we're offering a chemistry degree and a bachelor's degree also in biochemistry and a minor in chemistry. And we put at some point here a Word file together with 4-year plans for various options. Some students might be more interested in making things or synthesis interested. Some students might be more interested in careers that is more with measuring and working with dials and buttons and instruments and those kind of activities. And that would be more analytical, quantitative interested. So we have certain patterns for this to optimize your preparation for those type of career choices. We also have a degree that is certified by the ACS. It's kind of like a super version of your chemistry degree of additional coursework beyond the chemistry degree. And in old days, it gave you actually a higher starting payment when you take a job. These days, it's just basically to make sure that you are as prepared as possible before going on, for example, to graduate school. We have hopefully starting next fall, so fall 2021, a new program that's interdepartmental with psychology and biology, a neuroscience program. I want to point that out too. So it's not up officially, but we hope very soon. And students who would like to become high school teachers, we also have, of course, that option available to become a high school chemistry teacher, and that would be this program here. Now, it's also interesting to keep in mind what else might be out there that may not be quite obvious as a chemist. For example, if you're very good in writing, maybe a career in journalism is not a bad idea. Journalists have to report once in a while also science issues, and that could be right about the alley for you. Similar with communications and even forensics. With the criminal justice department, they have a minor in forensics. With like 3 more courses or so, you would be qualified for a minor in forensics. Mathematics is a similar scenario. We already ask our students in chemistry degree program to go all the way to calculus 3. And that means you're pretty close to a math minor, could be of interest. Or maybe you see yourself down the line in a managing area. Some of the industries are, of course, chemical industries, and it doesn't hurt maybe to know a little bit about business or finance. Okay, so we have patterns for each one of them. But let me begin here now with the PowerPoint to show the team. So on the left side here, you see myself. I'm Dr. Hoffman. I'm a physical chemist by training and chair of the department. We have 2 biochemists, Dr. Blows and Dr. Saputo. We also have 2 analytical chemists, Dr. Mark Heitz and Dr. Uhr. And just for this year joining us, our organic chemist is Dr. Kottman, and Dr. Reed is covering inorganic chemistry. We have a lecturer as well, and she has a PhD in marine chemistry. So we have pretty much covered all the areas in chemistry in our department, which is an important aspect to also realize. Since we have not a graduate program, that means that we faculty teach really all the courses. We have a few adjuncts here and there, but even them, they have oftentimes a PhD. They must have at least a master's to teach in the first place. In large R1 institutions, the staff professor doesn't really do all the teaching. It will be graduate students that do the teaching of the laboratories. Here, laboratories will be taught by mostly PhD chemists. This slide is to point out that our building, Smith Hall, has undergone complete renovation in 2011-2012. It reopened in 2012. Hard to believe it's already 8 years ago, but it still feels and is fairly new and fresh and is in good shape. So that renovation was also supported by the National Science Foundation by 1.5 million out of the total of like 15 million. That actually got that really started, this renovation. Very thankful for that support at the time. Our students are quite active. We make sure that we offer as much as possible opportunities for them to engage in research, including the summer. The campus has a program, we'll talk more about in another slide in a moment, to support campus-wide students for summer research, but we have also our own funds. And these are pictures from students doing research or then presenting at various local areas or at Scholars Day. It's another particular aspect about our college. We're one of the first ones, probably even in the country, that since in the 80s, we offer one day where we halt basically and devote our time to share our research endeavors. That is a great opportunity for students to practice professionalism in presenting their research as a poster or also a talk. We have other venues in the area. The Rochester Academy of Sciences has a venue in the fall. We'll join frequently there. The American Chemical Society, Rochester local section, similar thing. And we also go regularly to the National Conference of Undergrad Research, where we send students from all over the campus there, which is a great opportunity. Yeah, and you can see in the summer of 2018, we had a large crowd here. So a couple of students came from other places to us. We had 2 students from Germany joining us because of a research collaboration there, and we managed to actually get a little bit of exchange of researchers. So I have actually taken students to Germany to do research there. Okay, cool. So Chem Club is another interesting point to make. Our current Chem Club is actually really active despite the pandemic, or maybe because of it. They're offering tutoring to local high schools. They came up with this idea and made the moves, and they started this now. They involved also other clubs on campus. I believe biology, if I remember correctly, being told. So that's a wonderful thing, new development just happening. So yeah, and first year for students would typically involve taking college chemistry right away. We'd like to see if they can also get calculus once started. It may have to wait. So it could be first pre-calculus and then calculus, depending what the state of affair is. Everything builds on Gen Chem. So all the other courses follow then in sophomore and junior and eventually senior year. We have a capstone experience. That's the seminar. Students will have to dive as part of the seminar 1 year experience into one topic of choice, dig out one paper that's really from the primary literature and become a mini expert in that, and then present about that in seminar in a 30-minute presentation. And we provide mentorship for this experience so that students can really have a one-on-one capstone experience in that way. Cool. Yeah, next is a slide to point out that campus-wide we have GEP 100. It's kind of an extended orientation. Our department provides also one instructor for that, and typically there's a bunch of our majors in that section as well. So we'll start advisement with GEP 100, as is campus-wide the case, and then we assign majors their own advisor. Yeah. So I mentioned the summer research opportunities. We have some own funds as well, which is great. So we can support 2, 3, sometimes even more students in the summer with own resources beyond our campus-wide summer undergraduate research programs. So for biochemistry, similar scenario. We'll start with college chemistry and pre-calculus. So as a matter of fact, it almost does not matter if you don't know quite yet which science you want to do. If you do chemistry in your first year and math courses, you'll be in good shape. You can still complete all kinds of majors, not just in chemistry, but also physics or biology. They all require chemistry anyway. So first year, you basically make sure you have some math course and college chemistry, and then you can kind of sort out which way you really want to go. All right, and internship opportunities exist too. Constantly ask our alumni, and we'll get here and there some opportunities that way, and immediately share that with our majors. So some have done also experiences outside the college during the summer times and done an internship, for example, for Arco National Lab or with Eastman Kodak company. They come and go, these opportunities. They're not steady necessarily, but they are there. We have our students gone. Quite a few of our students are moving forward with graduate studies, all the way up to a PhD. And they go to all kinds of places in this country. Many, though, do stay in the area. So U of R and Buffalo are certainly like 1 or 2 students a year on average between these two alone. But they have gone to other places, Purdue, Maryland, Florida State, Michigan. You see the names. So it's quite possible to get into programs like that. Yeah, and the other large half or so is moving on directly into employment. And that could be local. Some move away and then find a job there. It just depends. But most stay actually in the area. And we do have, of course, also high school teachers. I mentioned that earlier. And they stay usually in New York State area. So it's 1 or 2 per year that become high school teachers. And some make it into medicine, in a medical degree, so in School of Medicines. That's actually increasing number, I would say, over the years. Good. A few pictures of our labs here. That, for example, is Dr. Lesueur working with his 2 research students. They've just graduated last spring and doing fine. Yeah, our general laboratory spaces for College Chemistry 1. And log in here again. Here's my contact. Yeah, so these lab spaces need to be such in shape that we can, in 3 hours, start everything and finish everything. So that's why they look really clean throughout the year like that, because we cannot accumulate stuff like that from lab section to the next lab section. It has to be always nicely moved and cleaned away. Unlike in higher level courses like physical chemistry, inorganic chemistry, and such, here we can leave some equipment out and do easily multi-week experiments and have a little more flexibility in that sense. We also use then instrument rooms. So our instruments are spread out over several smaller rooms. This one here showing our optical instruments to the left here. These are spectroscopy type experiments. And on the right side is for metal analysis and electrochemistry. This is the room for separations. We're very well equipped there. We have 2 gas chromatography units and another one even with a mass spectrometry detection unit. That's really what the forensic chemists will use. And liquid chromatography is also available. And these 2 instruments here, this is to find out what kind of chemical compound were you preparing. One is the infrared spectrometer, and the other one is very heavily used in our department for various courses as well as research. So a nuclear magnetic resonance instrument. This is essentially your MRI, except you don't put body parts in there. we put instead chemical in there and see what we actually made. These research spaces is for organic chemistry to the right and biochemistry to the left. And we have also social spaces around. We actually have a very nice kitchen area, so students can maybe reheat something or make something instead of buying expensive food. There's some lockers available. You can just ask, and usually there's not as much run of them, surprisingly, but it's kind of nice. You can leave your goggles in there, your shoes or so. You never forget about them. Especially summertime, you have to remember to have proper shoe work, and sometimes one forgets. So if you leave a pair of sneakers in there, you'll be always in good shape. Yeah. So if you have more questions, you can contact me at this address here, iman@brockport.edu, or call me at this number. That concludes the presentation.